Ladies and gentlemen, welcome back to Zeiss Innovation Rocks. My name is Pietro, I'm your host, and this is rock number 7. In the last 2 episodes, rock number 5 and number 6, we introduced you to the world of Zeiss optics. In this episode, we will focus on the topic of defect detection. And to get a better understanding of Zeiss defect detection, today I will talk not to one, but to 2 expert guests. My first guest is Head of X-Ray at Zeiss. Welcome, Petra Schmidt. Hello, Petra.
Hello, Pietro.
And my second guest is connected with us from the United States. He is the Head of Additive Manufacturing Process and Control at Zeiss. Welcome, Marcin Bauza.
Hello, everyone.
Hello, Marcin. Marcin, I start with you. What is defect detection all about?
So in mass production, we creating a lot of parts. It is important to find if all the conditions are met. So sometimes parts may have critical issues on the surfaces or internal issues, and we have external defects or cosmetic defects on the parts. And also we will have functional defects on the parts that could be on the surface or internally.
Okay. Well, Petra, let's focus on functional defects. What exactly are we talking about?
So when it comes to functional defects, they can be actually both on the surface of the part or hidden inside the part. And they influence largely the stability and the lifetime of the part. Very important with functional defects, it's not only to find them, but also to set them into the right context.
Okay, so basically in this rock we focus on 2 technologies. One allows you to inspect the outside of a part, and one allows you to inspect the inside of a part. So now let's take a look at the first of these 2 technologies. So this is Zeiss SurfMax. Marcin, what have we basically just seen?
As you mentioned, SurfMax, it's that high-speed inspection of surfaces. We're not measuring the surface, we're looking for surface defects, we're looking for cosmetic appearance, so ensure that the product looks good, and that's the technology that's going to support this.
Okay, thank you. Well, now it's time to take a sneak peek of the second technology. Zeiss Volumex 9 Flash. Same question for you, Petra. What exactly have we just seen?
You have seen the inline solution for large aluminium casting parts, 100% inspection, finding the critical defects in no time.
All right, so Zeiss Volumex and the SurfMax can let you know if there are any defects on a part. But can they also help you in identifying the type of defect?
Well, you hit on a very, very important point, because both solutions can not only find the defects, but they can classify what type of defect it is. As in a 3D volume, for example, pores, shrinkage holes, cracks, and so on.
Marcin, would you like to add anything?
Absolutely. As you can imagine, the defects on the surface will be a little bit different. We absolutely can detect many different kind of defects, but the typical ones are scratches, dents. If you're doing some coating process, those could be fingerprints, also polishing problems, orange peels, and paint runs. And all of those can be classified and named properly.
Okay, both SurfMax and Volumex are inline devices. Does that mean that each and every defected part gets automatically rejected?
At first we're looking, does the part has any imperfections in the surface? As we can imagine, we can see smaller or larger imperfections, and now depends on the sensitivity and what customer really is looking for, we will classify them as okay imperfections or acceptable or not okay imperfections, and this in case will be those named as a defect. And yes, those defects will be rejected and sorted out.
So actually, once one customer told me, until you showed me the inside of my part, I could sleep actually really well. Now that I've seen how many defects are in there, I can't sleep anymore. Luckily, we had a software solution for him for distinguishing the critical defects from the non-critical defects that makes him sleep again.
Okay, but is it absolutely necessary to check each and every part? Wouldn't it be enough to do like samples testing?
The problem with defect detection, they are typically random. So we like it or not, we have to do it at 100%. We have to see every single part. We have to trace down what is really happening. And this is the complexity here. And also with defect detection, we need to look on overkill and escape. We want to make sure that we're not detecting something too severely on the parts that are acceptable, and we're not letting out components that are not acceptable for use. So those are the escapes.
Okay.
And also in a lot of industries, there are actually quality standards that ensure the safety of the product for us as end users. This is why our customers really inspect 100% of the parts. In addition, once you learn something about the defects in your part, you can also improve your production process to produce less bad parts. That means early detection of defects, less scrap, reduction of costs.
Okay, well, all of this makes sense, but isn't it very time consuming if you control and inspect each and every part? I mean, one would think that these will, slow down the entire production process, which is the last thing that you want.
The production cycle time is given, and we find a solution for the customer that is inspecting the product within the cycle time.
Martin, anything to add?
As Petra mentioned, the inspection already is happening. There is a certain time slot, and today visual inspection is already performed by different means. What we're adding here is ability to do it digitally, to record the results, and to be able to compare the entire batch runs, and that's the additional benefit. So there's no add-on of time.
Okay, well, Martin and Petra, thank you very much for this first round of explanations. Now it's time to take a closer look at Zeiss SurfMax. Marcin, you're the head of this field of business. So what about this product makes you particularly proud?
This was not simple. We had to create a very specific hardware, but we also had to create a very impressive software. It's not only the accuracy of the software, but also extreme speeds that are required to provide information in a live time.
Okay, well, now it's time to see SurfMax in action. And for this, we have sent our demonstrations chief, Jay, to the United States, where, along with Stephanie, he has recorded a demonstration video. Let's watch it.
Hey,
Stephanie, how are you, my friend?
Great. How are you doing?
I'm good. It's good to see you.
Welcome.
Thanks for having me. It's good to be home. Let's start at the beginning. What's your name? What do you do?
Sure. I'm Stephanie Kobayashi, and I'm the SurfMax product manager here in Maple Grove, Minnesota. Right behind us, this is our R series. This is our R150 system. And if I open it up, it's called the R series because we have a big robotic arm integrated right into the system. So this helps us with part handling.
Sure. And I see you painted it black to make it look cool.
Yeah, that's right. So we specifically use this system for parts that have very complex sorts of geometries. So the example we'll cover in a little bit here is this orthopedic knee.
Okay, so I see that there's two different kinds of machines. What's the difference between this one and that one?
So the other system is our S series, and we use that for flatter, more planar types of surfaces, much like consumer electronics parts, like the smartphone that we have here. So the S on that system stands for staging system, and it's going to be very high throughput system where the part is just going to go through the tunnel rather than being picked up and manipulated with the robotic arm.
And so again, that's looking for different types of defects on the surface, right?
Yeah, that's right. With consumer electronics parts, oftentimes we're really concerned with cosmetic types of defects. You wouldn't want to get a new phone, open it up, and see a big scratch on the surface of that. When we're talking about airfoils or the orthopedic knee, we're more concerned with functionality of the parts.
So that's a little bit about what we do. How do we do it?
Yeah. So we use Zeiss optics to image our parts, which is not new for Zeiss. We've done it for a very long time and we do it very well. But what really makes this system unique is that we package it with in-house developed software and algorithms for defect detection. So we're really getting the full package for reliable defect detection.
That sounds awesome, but it sounds like it takes a lot of time. What's the cycle time on these guys?
You would be surprised. For the smartphone we looked at, it could just be a couple of seconds to meet that cycle time. So really quick, and for something more complex, like the orthopedic knee, we're talking maybe 60 seconds, around a minute.
60 seconds for an orthopedic knee? That takes me usually about, 30 minutes to measure. I am dying to see it.
Yeah, thanks. All right. We'll go ahead and get this started. So I'm just starting the acquisition, and the part is picked up, and it's going to be oriented by the robotic arm in a number of positions in front of that ring of cameras we can see in the back.
How many images are we actually taking?
Yeah, so it's about 65 raw images times the 5 cameras. So it's about 300 images that we're working with.
So you are picking up in the span of, this part was 60 seconds, right?
Yeah, 60 seconds cycle time.
You're able to pick up about 300 or so images in that short amount of time.
That's right. So let me show you what we do with those images once we have acquired them.
Okay.
So the SurfMax has acquired a number of images for us, and we can analyze these images on a number of different channels. So we use gloss, grayscale, and slope channels of information to detect certain types of defects.
Got it.
And what we're able to do is use PyWeb to look at these defects. So shall we take a look at the part?
Yeah, let's see it.
All right, so on our report, we could see about here, there was a defect on the surface there. It's definitely hard to see with the naked eye, that's for sure.
Well, Stephanie, that is crazy. It's amazing. This is definitely a world that I'm not used to seeing at all. Thanks for showing us. This is really, really new stuff, right?
Yeah, absolutely, yeah.
I have questions, I'm sure others do too. You're going to do a webinar after this, right?
That's right,
So
yeah.
if there are any questions, certainly you're going to be the person to answer it.
Yeah, looking forward to it.
That's great. Stephanie, great to see you.
Good to see you.
And with that, we will turn it back over to you in the studio.
Well, thank you very much, Stephanie and Jay. That was Zeiss SurfMax. And now I'm pretty sure that everybody here and everybody at home can't wait to get more insights into X-ray inspection with Zeiss VolumeX. So let's get them. Petra, before I asked Marcin how proud he was of his product. So same question to you. What about you? How proud are you?
I'm particularly proud about the team that developed that product.
Okay.
Because it's helped our customers saving a lot of money. It makes it possible to detect the defects early on, so the customer is not wasting any resources or money in further producing parts that in the end won't do the job. We had one customer use case where the entire solution amortized within the first year.
So ROI in less than 1 year.
Absolutely.
Wow, that's the dream of every customer. But I know that there are even more benefits, especially when we think of the combination between Zeiss Volumax 9 Flash and the new Zeiss automated defect detection software. Am I right?
You're totally right. Typically you have the trade-off. Either you have a small part with less material that you can inspect very fast, or you have a large part with more material that typically takes more time to evaluate. Now with that solution, it's actually possible to really achieve high throughput also for the large parts with more material.
For example?
Engine blocks
Okay.
within less than 60 seconds.
Oh, come on, an entire engine block in less than 60 seconds.
You got it.
How in the world is that possible?
Well, as you said, it's the combination of hardware and software. On the hardware side, we used a brighter source, and our Zeiss expert invented a new detector concept that makes that possible. On the software side, classical concept won't do it. We are working with artificial intelligence to make that happen. Because of the bigger parts, we have more data. And out of that more data, namely 4 billion voxels, we find these 10 voxels that mark the smallest defect within that less than 60 seconds.
Impressive. Well, Petra, all of this sounds too good and too impressive to be true, but fortunately, here at Zeiss Innovation Rocks, we are not only about talking and promising, we're also about demonstrating. And therefore, we quickly hand over to Jay and to Benedict, who are here with us in the studio and who can't wait to demonstrate what we just talked about. Over to you, Jay.
Thank you all, appreciate it. I'm excited to dive into this, and with us is Benedict. Benedict, let's start at the beginning. Can you tell us about yourself?
For sure, yeah. My name is Benedict Imhoff. I'm working for the application development department for X-ray. And yeah, let's start with a short video that you get a first impression of how our system is used at the customer side. And as you can see, the system is fully integrated into the production line and can work fully automatically. So the system, let me say, is designed to run 24/7 and in a harsh environment like high temperature and so on.
Yeah.
So, for example, one of our customers scan 1,000 or even more parts per day. So I think that's a lot, and I'm still excited to see the systems running.
That is a lot. I mean, 1,000 parts per day, that's a pretty intense piece of hardware. Does that have something to do with that large detector that Petra was talking about?
Exactly. So with the in-house developed detector, we have now more possibilities to scan bigger parts as the engine block in a faster way. So compared to our smaller detector, we are now 30% faster.
30% faster. That is a huge improvement. Now, I know from my days as also I'm a product manager, sometimes with really intense hardware, you need really intense software to manage that. So I can imagine with that type of throughput and those big detectors, you must have a pretty impressive software to power that, right?
Exactly. So when we want to talk about the Zeiss automated defect detection, so from my point of view, it's a real game changer. I will tell you why, but at first let's show you the challenges of such an evaluation. Therefore, I prepared a scan part, and let's try to find defects by yourself and let me know if you find some.
You're going to have to help me.
Yes, I go
not
through.
Good at this, so there's a lot of scatter, so it's tough to.
Maybe you can see here on this side, on the upper side, so you
on the upper there. Yep. I see that there's something that could be a defect.
Exactly.
Is there anywhere else in here that?
And here in the corners, there is a rest stand or something.
Sure, that looks like it could be something for sure.
As you can see, maybe it's not as easy as you thought.
It's
at first.
really hard.
Yeah.
But especially if you don't know what you're looking for. Right?
Exactly. But you see the scattering in all the different CT artifacts, but that's not the problem.
Can you show us on our software?
Sure, I will show you that.
Oh, wow, that's really clear. You even highlighted it for us.
We are not focused on image quality, we are focused on performance. For this, we use a training approach where we scan 20 to 25 good parts and collecting features during this process. And this allows us to calculate a reference part, or so-called golden part. At the end, what you can see here, we have a reference part and a scan part, and at the end we see the deviation, and this is the real defect which we want to see. But that's not all. So when we're talking about the whole process, so the size automated defect detection is a combination between artificial intelligence and easy to adapt decision scheme. So when you see at the screen, so at first we want to detect the defect. Second, we want to know the error class. So is it a pour, is it a rest sand? And third, for sure, we also want to know more information about the specific defect, so volume size and the form maybe. And at the end, with all this information, we can decide if this is an okay part or not okay part, and we pass it through the next processing step. And last but not least, we can input all the information which we collected into our PyWeb, and you see we have different report possibilities. So based on customers' needs, and I think this is a great benefit for our customers.
A huge benefit. So if I think I'm hearing you correctly, what we have is a marriage between really, really intense, state-of-the-art hardware wrapped in a package that is shop floor hardened with some pretty intense software to help you cut out the fray and decide what is part and what is fray, and then a really good intelligence, artificial intelligence, to help you decide what is good and bad, all in one package, one-stop shop that we can deliver to our customers by Zeiss.
Exactly.
Perfect.
Yeah.
If anyone has any questions, what can they do?
We have our webinar, so I'm looking forward to see a lot of guys, and I'm waiting for a lot of questions.
Perfect. Benedict, thanks for showing this. And with that, I'll throw it back to you, Pietro and Petra and Marcin.
Jay and Benedict, thank you very much for this demonstration. And by the way, good to have you here in the studio finally.
It's good to see you in person finally.
Well, thank you very much as well to Petra and to Marcin. Petra is the head of X-ray at Zeiss, and Marcin is the head of additive manufacturing process and control at Zeiss. Well, this brings us to the end of Rock number 7. Right after this, the webinars will kick off. Be sure to click the link below to register for free and to join in. My name is Pietro. It's been a pleasure. Thanks for watching, and I see you next week for Rock number 8. Until then, bye-bye.